So, hi everyone, I am Christopher Hoffman. I am here to talk to you about resin printing. So I just got a resin printer, resin 3D printer sent to me yesterday, and I have learned a whole lot about it. So I'd like to walk you through what is resin printing, how is it different from the filament-based printers that we have, and show you some awesome models that I've done in the last 24 hours. So, resin printing 101, twice the detail at twice the expense. So, say hello to my new baby. It's kind of hard to see in the projector, but this is the XYZ printing, their Nobel 1.0A. It is a resin-based SLA printer. SLA is stereolithography. So there's a couple different methods of resin printing, which I'll get into. This is a method called stereolithography. And so instead of a spool of filament like those printers over on the side, this uses photopolymer resin, so resin that sets up under UV light. So, what are the pros and cons of resin printers? Well, some pros. It's very, very high resolution. So, normal filament printers, you can base the resolution off of the layer height, so that Z-axis. Filament printers print about 200 microns, so 0.2 millimeters. Usually the lower end of that layer height is 100 microns. That's kind of the finest detail that you can get. However, with resin printers, you can get much thinner layers, which equates to much higher resolution prints. You can get down to 25 microns per layer for these resin printers, which is really awesome. Multiple objects on a build plate do not affect print times. So if you were to take a standard filament printer and add more objects to the print, so the print bed, it would take that much longer. So if you had one object and it takes 2 hours, if you add a second object, it still has to print each one individually. So in total, it would take 4 hours, twice that there. But with a resin printer, it prints the entire build plate either in one pass or at one time, which per layer. So that means that if you stack the build plate and just fill the build plates, the print times are going to be relatively unaffected by that. So you can stack them up and not increase the print times. And they're also low powered. For instance, the printer that I have is 60 watts versus like 450 watts with a filament printer, because you don't have to heat up a hot end. You don't have a build plate to heat up. You don't have to have the hot ends at 230 degrees Celsius. So it requires lower power to run. However, there are some cons to these resin printers. First, it's much more expensive. Desktop kind of hobbyist SLA resin printers, they start at about, well, they used to start at about $3,000. The kind of frontmost runner in this was a company called Formlabs with their Form 1 and their Form 2. Those machines are about $3,000. If you compare that to some of these other printers around here that sit about $700, it's much more expensive. Also, besides the machine costs, the resin costs a lot more, consumable items, and there's post-processing steps that you have to take into consideration. For example, the resin, it costs about $120 per kilogram versus $20 for a spool of filaments. So it's much more expensive that way. Also, there are post-processing steps. So the objects, when they come out, they need to be rinsed in a solvent and cleaned off afterwards. So it's not just pull it off the print bed and you're good to go. Oop. Hold on, computer is not responding.
Can I interject the question?
Yes.
Is the resin, the UV curing resin, proprietary blend, or can you use any UV curing resin?
On this machine, it is a proprietary blend. They have a few different material types and a few different colors, but it is the bottle has a chip in it that keeps track of how much fluid's left in it, and if you try to refill the bottle or something, it won't let you. So they use the excuse of, we want to make sure and control that we have good good resin and that you're not going to ruin your machine, that kind of stuff. There we go. So Sorry about that. So another con is usually you have lower strength objects, although that depends on the resin. Definitely the cheaper printers, you are going to have slightly weaker objects than objects printed on the filament printers. The layers just don't adhere quite as well, and they tend to be, you tend to print them with very thin wall to preserve resin because it's so expensive, that kind of stuff. And also smaller build area. So for instance, my machine has a build area of about 5 inches by 5 inches by 8 inches. If you compare that, and that's larger than a lot of other resin-based printers. Usually they're very small build areas, but they make really good use of that. So how does this work? Well, objects get pulled from ooze. You have a vat, a tank filled with the resin, and then so the build platform, which is what it's adhered to, gets lowered into the vat of resin. The vat has a clear bottom, and that underneath the bottom sits either a UV laser, that's what SLA printers use, or a projector for digital light projection, DLP printers. So either it's a laser shining in underneath, curing the resin, or it's a projector projecting an image onto the whole build area to cure that resin. So light shines up, it cures a single layer, so it is still a layer by layer process. The platform then moves up and the process repeats. Another layer is shown on, it cures, and the layer gets pulled up. So there are some interesting mechanics that you won't see on a filament-based printer. If you notice this, every time a layer is done, the vat kind of goes down. So the cured resin actually adheres to the bottom of that vat as well as the object on the build plate. So it kind of glues itself to the vat. And then the vat has to peel itself off of that newly formed layer. So you have this new object, and it dips down and rips itself off of the bottom. And that peeling and wiping is kind of the big problem of the resin printing. It generates a lot of force on that object as it pulls itself away. And that large force tends to increase the chance of failure of those prints. Question?
Is this video real time or sped up or slowed down?
This video, I think this is real time, maybe a little sped up, but it's about that fast for a DLP printer. And you can think that every time that it moves down, that's another 25 micron layer. So it has to print a lot of layers to print anything large. I don't know what happened there. Yeah, so this large force is kind of a problem because as it peels itself off, it has to, it removes a little bit of, there's a silicone coating on the bottom of the vat to help that peeling process, but over time that silicone layer kind of wears away. So the bottom of the vat starts to become cloudy and it's harder to print in that area. So generally you want to spread out your prints as you print them throughout all of the build vats, so that it's equally worn in all of the areas. And then when the build vat gets worn away too much, you just pull it off, buy a new one, replace it. So that is an added expense. That's one of those consumable items, is actually that tank, just because of this peeling process. Question?
Tell me, is it better or worse at printing flat surfaces?
So worse. That actually leads in perfect. So normally with a filament printer, you want large flat surface. You want it to adhere to the print bed. You don't want any warping. That's a problem with resin printers. So for resin printers, if you have a large flat object, you don't want to do it there because as it tries to peel itself off, that's a lot of force. And it's probably going to either not peel and then you have a ruined print, or pull the entire thing off and then you have a ruined print, or any combination and you have a ruined print. So for large flat objects, you generally want to print them sideways at an angle, so there's only a little bit printed at a time to reduce that net force from the wiping procedure. And you can see that it reduces force, but it requires you to use a lot more support material. So support material is very, very important when doing these resin printers. You want to use a lot of support that you then afterwards have to remove with pliers or tweezers, or cut it away with X-Acto knives. So that's just something to keep in mind, is that tons of supports are required, and large flat objects, you generally want to print them at an angle. So
and this is printed.
This would be printed upside down. So the bottom of where all these supports touch, that would actually be flipped upside down, and that would be the first layer printed on the build plates. So here is a video of my printer in action. Just kind of a camera shown through. So you can see, oh, that's really hard to see on this projector. You can see the laser lights kind of moving around the objects. And so here's the front of it. And then the build flat lowers, doing that peeling process. And that was one layer. That was one 100 micron layer.
The lasers move by mirrors, is that right? Or by...
No, so the laser underneath is actually, you can think of it as a, or I believe it's kind of like a flatbed scanner. So it's a bar that crosses, that spans the entire x-axis, and it kind of just moves forward underneath the build plates, shining. I don't know if the lasers are on there or it might be some sort of mirror underneath. I'm not 100% sure. But it goes from the back, moves forward, doing that entire x-axis at one pass. So I can play that again while we answer another question.
How do the X and Y resolutions compare with the Z resolution?
So the X and the Y resolutions, I believe, are 13 microns. I believe that's right. So I think that it has like you can think of them as pixels or something like that. But 13 microns, so twice the resolution of the X or the Z axis. So you can get some really, really nice detailed prints out of this thing. So
twice the detail was really an understatement.
Correct.
Compared to the filament.
Correct. Compared to the filament, you can get a lot of detail out of these things. And I'll pass around some prints and you can actually see that in person. So post-processing is the same. Why is this not? Yeah. I'll just go. So post-processing, when you pull it off the print bed, since it's pulled from that resin, it's still covered in uncured resin. So you want to scrape off the build plates, like the rest of the resin from the build plate. Make sure you save that because this resin's really expensive. And then you pull the print off of the print bed and you dunk it into some kind of solvent. Usually rubbing alcohol, that's what I've been using, but each resin type is different. You just have to make sure you know what to rinse with. So I dunk mine in alcohol, have a little brush to brush off some of the uncured resin, and then after about 10 minutes or so, I pull the object out, you dry it, and then you're ready to go. Another thing is these are, my particular one's cured by UV lights, so the laser doesn't cure it to 100%. It cures it enough to print the object, but I found that when I pulled it off, you can still feel it's slightly mushy, slightly not as strong as I think it should be. So what I did was I actually left mine out in the sun today to let the sun's UV rays really like kind of bake that resin, and it actually improved the strength quite significantly. So there may be other additional curing that you have to do afterwards to achieve full strength.
Have you compared just leaving it for a day in a dark room and leaving it for a day outside?
I have not, because I've had it for 24 hours and I have not thought about that. But yeah, I should do that exactly. So here's some preliminary results. I will start passing some of these around. They're really, before I show them up, so they're really good at printing things like miniatures. So if you've ever tried to print a miniature on one of these printers, they're way too small. These are inch by inch base things, and the person, they're tiny. So you would never be able to have the resolution to print an object like this on one of those machines. It would be really, really difficult to do. Question?
Did you have an idea for how much it took to produce those miniatures in resin?
So resin cost for these, they're really small, so they actually are only like 3 grams. So if you consider $120 per kilogram at 3 grams, this is about like 40 cents worth of resin. So since it's very small, you can print a lot with that resin.
Well, there's also waste in resin during the process too, right?
Correct. I'm not sure exactly how many of these you'd be able to crank out. So
they're probably under $1.
yeah, probably total cost would be under $1 or so. Question?
So you could make like little figurines, like Warhammer type figures.
Exactly. So that's one that I've made, was something for D&D. So the objects passing around, these are a couple of them. I have a D&D character. I have a hollow Buddha, Stormtrooper Buddha passing around. I have a little glass that has some etching and stuff, some nice designs around the side. And then I also have a Voltron keycap, so for a key for a mechanical keyboard floating around. So afterwards, if you don't see one of these, you can come see me and take a look at it under the light. You know, get some good pictures and stuff of it. Yes.
Do you mind if I take a picture of it?
No, go ahead. Take some pictures, spread it around. So you can see that the detail, if you look at it, is really, really good. It's really hard to see the individual layers of each one. My favorite is the Voltron keycap, because if you hold it up into the light, you'd be able to see the individual layers, because it's a very shallow, kind of like curved on the top. So around the sides, you can see that kind of layering effect, and it's very crisp and very clean. And I think that was, yeah. So take a look at them, pass them around, make sure you see all the things. If you don't see them, I'll collect them afterwards, and you can get a nice good look at it. But that has been my resin printing 101, kind of a quick overview, stuff that I have learned in the past 24 hours. The machine that I have, I'll have for at least 30 days. Maybe I'll end up buying it at the end, who knows? Depends on how much I really like it. The machine, by the way, the cost of the machine that I'm using is $1,500. So XYZ Printing is trying to get into the SLA market, and that machine is one of the lowest cost SLA resin-based printers that is out there on the market today. So if you're interested in it, you don't have to spend $3,000. You can do some pretty cool things with a less expensive machine. And I'm expecting those prices to actually start dropping now that there's more companies competing in that space and that kind of stuff.
You think there's any way to make it less of a pain in the ass?
Probably not. There's a lot of like the post-processing and all of that. The resin, like when you pull it off, you'll want to wear gloves because the resin's very viscous. It also sticks. It's very sticky. If you spill some on your carpet, say goodbye to your carpets. That kind of stuff, you're probably not going to clean it off of cloth. So wear gloves. You don't want it on your skin. You also do not want, if I go back to the beginning where I show my machine, all of these printers will have some kind of hood, some kind of shield on the top, because it is UV cured. So if there wasn't a shield around it, then you leave yours by the windowsill. If there's any resin left in the build vat, then it would just get cured. You'd come back and you'd have no resin left. You'd just have a build full of photopolymer. So you'd have some kind of hood. There's a lot of different designs out there, but just you'd want to be careful when you pull it off, not to leave it out for too long, those kind of things. So it is a big pain in the butt to use these machines. Yes?
The practicality of this, how does it compare to a filament printer?
The practicality is if you need to print small things, really detailed objects, this would be great for you. If you're trying to print larger things or structural things, so mechanical parts, that kind of stuff, you would want to go with a filament-based printer. Starting off, it all depends on the printer itself. This was relatively easy to get going. There was one kind of calibration process when you pull it out to make sure that the build plate is level with the rest of that vat. But it was just that one calibration, and then you're good to go. I don't know yet about long-term life or how many prints I can do before I have to replace the build vats or any of those other mechanics. I just haven't had the printer enough for that. So it's all based on your use case and what you want to print with it, that kind of stuff.
So you said there's multiple kinds of resin?
There's a few different types. I'm not 100% sure of what XYZ offers. I know that they have a strong resin, which is what this clear is, that comes in a few different colors besides clear so that they're pigmented. And then they have a castable resin and a flexible resin. So the flexible resin obviously has flex afterwards. The castable one, I believe, is for use for jewelry, for making molds and casting metal parts out of these printed parts. So you would actually print the object, you would make an investment mold of that. you would then burn out that printed part made in that castable resin. It's designed to burn out cleanly. Then you would pour in your metal and you'd have a casted object. So those are the three types that I know that XYZ has. Other brands of printers may have other brands of filament that do slightly different things, but those don't work in this particular machine. So, but that's what the object here is. They're clear, and it's supposed to be they're stiff, they're strong resin. So, question.
Is there a corresponding reversible process to restore your resin?
I do not believe so. I don't know 100% if you can reverse that process somehow. Everything that I've read online is once it's cured, you're not going to be able to do anything about it. I'm not 100% sure about that. I don't know all of the physics behind the material science and all that kind of stuff. So, but I don't believe so. Yes?
So apparently, I guess your laser beam is about 12 microns in diameter?
Something along those lines. It's very, very thin. It's really cool to watch it print. I don't know if it does scan across multiple times fast enough for me not to be able to tell, or if it is one full width beam going over that has like shutters to turn it off or on and off. I'm not 100% sure, but I know that it's very, very detailed, much finer detailed than the 400 micron nozzle of a filament-based printer.
So you have a dual extrusion, I think PLA. Are there any resin multiple types that are used in the machines?
Not that I know of, because it's all one vat filled with the liquid that it goes down into. It'd be really difficult to kind of separate the liquids, or there may be something based on strength, the different strengths of lasers. So maybe you would have a part that's not fully cured for support material, but I haven't seen anything like that. I've only seen single material, single kind of strength objects printed from this. Any other questions? Yes.
Can you talk about the different resins? Some are proprietary, some are not. What are the differences in the machines? You know anything about those? Or?
So the differences in the machines, there's a couple different ones. Like I said, the Form 1 is kind of the premier object, and that's also an SLA printer, which is the same as this. It has a slightly smaller build size, but it's been out for a couple of years. People really like it. It delivers really high quality prints. I just don't know. I don't know of the. I can't really talk about the differences because I just don't have experience with that. This technology has been used in giant engineering firms. Like SLA printers have been around for a while. So you'll see some really expensive machines in engineering firms that have giant build areas. And there's a few different techniques. Most of them are shined underneath and the object's pulled out. There's a couple of them that have the build plate in the vat and the light shines on the surface of the resin, and then the build plate kind of lowers. But that's harder to do because you need to make sure that the resin, there's enough resin in order to cover the part, and there's a lot more mechanical stuff involved in that. One popular machine that kind of made waves about 6 months ago, you've probably seen a video. It's actually the video that I used in the first GIF here. Let me go through this. So this machine, you've probably seen a GIF around the internet like this, or some of TED Talk. This is the Carbon 3D. It made huge waves in the 3D printing community because it was like, print 80 times faster than your normal 3D printer. Print this object in, 7 minutes or something like that, where that would normally take like an hour and a half in a typical 3D printer. This is I believe it's an SLA printer, might be DLP. It's a resin-based printer either way. But they have a special secret sauce where instead of the bottom layer being just glass, they have an extra layer on the bottom that allows them to control the oxygen content in that area. So by controlling the oxygen content as well as the light intensity, they're able to not really generate layers, but this kind of continual motion, this continual printing, because the oxygen helps to inhibit the curing of the resin in certain areas, and they can control that very precisely. However, this is not going to be for your typical home desktop printers. These are like $100,000 machines that you rent per year for engineering firms. So if you need really, really high quality stuff printed really fast and you have $100 grand a year to spend on renting a machine, Carbon 3D, they're an up-and-comer to the industry and printing really cool stuff. Question?
Do you know what companies?
Do I know what?
Do you know like products that use these or companies?
Products that use prints from these as things? That I'm not 100% sure about. I know that there's a lot of people that are using these for decorative objects. Obviously, there's engineering firms that have paid Carbon 3D for these $100,000 machines, so they're doing something with it. I'm just not 100% sure. The prints from these are really hard to tell apart from things like injection molded pieces, so you're probably going to see a lot more 3D printed parts afterwards, like used straight from the print bed rather than injection molded parts, but I don't know off the top of my head, so can't really say that.
Do you know if the mechanical properties compared to injection molded parts?
I do not know. So I wouldn't be able to tell you that difference. Yes?
I wanted to add, one of the things I think I know they do is they sell polymers that are meant to be burned out with fire. So the intention is you print jewelry, make a cast of that and burn out the printed part and then fill it with metal, presumably gold or silver or whatever your preference is.
Yep, that's a big one, especially since the detail, you can get really fine detail. It's perfect for jewelry. It's perfect for, earrings, rings. Actually, there was a ring passed. That's another one. So I was passed around a ring. The ring was the very first one that I printed. It failed in the print bed. It actually there wasn't enough supports. So there was like 5 support columns that came down, and that peeling force was enough to break off 2 of the supports. So it was moving each and every layer. So you can tell that there's a little broken piece on the ring, and the layers didn't quite match up. And then the second print was the little glass that went around. And if you notice, the glass had a lot of Z-banding. So there was a nice decorative piece, but the glass, you could see like 1 millimeter layers kind of going up. And so I pulled this off and I was like, why? This is terrible. What's going on with this printer? I realized, if I can borrow the glass, so layers going up like this. I realized that it was printed like this in the print bed, and when it was pulling out, there was no other support material. So it was supported solely by the stem, and this stem was really weak when it was coming out. So since it was just being printed and had to peel itself off the print bed each layer, this tended to move just slightly each and every layer. So that resulted in the banding shown. Now the third print that I did was the Buddha, and the Buddha turned out amazing. I pulled this out, I was like, this is what I was expecting. So I realized then that it was the structure of the part that made it strong enough not to warp, not to move, and then learned that you should have a lot of support material, really use those supports. One other quick thing about the Buddha is you'll notice that there's 3 holes in the back. That is because I wanted to print this hollow to save on resin, because if you print this thing completely solid, there is no such thing as like infill percentage. So like in the filament printers, you'll have an infill that's like a honeycomb shape, and you say, hey, fill 5% of it with this honeycomb, and it can do it. Usually with these parts, there are no infill. It's either completely solid or you do your own thing, because when it prints, you'll have the resin trapped in the middle of it. Each of those honeycombs would be filled with resin, and it would be really difficult to put in those honeycombs and add a series of holes and drains to drain that out. So I did this manually. I took this into Mesh Mixer, I made it hollow, gave it a wall thickness of 1.5 millimeters, and then placed 3 holes in the model so that I could drain the filament as it prints. It could pull air into it, make sure that everything drains properly. So yeah, that's draining. More questions?
What about making a double wall thing and add those holes in the slicer wherever they go, and then putting like cheap photopoxy in there?
You could definitely do that afterwards. That would be a way to increase strength. So he's saying
So you're printing a coffee mug and you don't want a 1/4 inch thick wall of your expensive material, but you can make all the fancy stuff on the outside and a bunch of interior beams and then just fill it up after.
Yep. So I could take like a hot glue gun, resin, whatever, inject it in afterwards, cure it, and that's a thing you can definitely do. You can also do that with normal filament-based printers. People have used hot glue and injecting it into that infill to increase strength. So theoretically, you could do the same with this. A few more questions, and then I'll get out of here. Yes?
Do they have like something based on this, like using like some kind of alloy metal?
Kind of. There's a few different methods of that, kind of outside the scope of here, but if you're interested, laser sintering is a common way to make metal parts, selective laser sintering. There's also, if you want to go a powder route, there's layers of powder that has epoxy dripped into it. That's how you can get some of the full colored prints. And as far as I know, there's nothing like pulling a print out of a vat of liquid of molten metal. I don't think they're quite at that stage. But metal powder censored together with lasers, trying to talk too fast, is definitely a thing. Yes?
Other surface treatment tricks like the acetone for ABS?
That I'm not 100% sure. A coworker was asking me about polishing. I don't know the properties of this particular resin, so I don't know if it takes a polish well. With ABS parts, you could put it in an acetone bath, and that kind of eats away the ABS, giving a nice smooth finish afterwards. I'm not sure if there's the same process for these resins. I just haven't looked into it. It's a good question, though. Any more? Yes.
When it comes to removing the support structures, what is your preferred method for doing that? Like with a Dremel or something?
They're actually really weak if you pull them off immediately following kind of washing it off in the alcohol. So I've actually just taken a pair of tweezers, grabbed them, and that's enough to rip them off. You can control how strong those pillars are. So it basically starts, if it's on the build plate, then it's a full column. If it starts on a piece of print, it's a very thin support, grows to a thick column, and then back to a point. And you can control how thick that point is at the end and how thick the pillar is. But the ones that I've done is just basically grab a pair of tweezers, pull them right off. And it's really hard to tell where the supports ended and where they began.
Why do you want the support to be thick in the middle and thin at the bottom?
Because each of those pooling effects, if it's thin, then it tends to warp, and it may move when the next layer kind of gets on. So you may not have a very strong column going up. So you want it relatively thick so that it doesn't deflect under that force. And you want it thin where it attaches to the print so that it's easy to remove, but there's still enough material there to seed to kind of grow the rest of the part that it's supporting. How many more questions? Anything else? I got one here. Anyone else have a question? You got two more questions. You'll be the last ones. Yes?
Is there an open source version of this?
There's a couple open sourced ones. I haven't seen one that has kind of like taken off. I haven't seen like a RepRap project of SLA printers. There's a couple people that are trying to make one, but their kind of bill of material still around like $1,000, and the quality hasn't been, it hasn't generated enough interest from the community to really jump in and go. I'm trying to remember the names off the top of my head. I can't recall any, but if you just search for some open source SLA or open source DLP, you may be able to find some open source projects. Last question.
Sounds like your build plate comes down within a few microns of your bottom plate, and so when it's pulling up, it's ripping loose from the bottom thing. So is there a calibration process for getting that build plate to the bottom of the...
I actually don't believe so. At least with mine, there wasn't any Z kind of calibration, so I didn't have to like lower it down, put a piece of paper under it, and get it exactly right. I did have to do what they call horizon calibration, which was basically it lowered it all the way down, and then I just pressed it down into the vat, so that the vat's horizon, that horizontal component, and the build plate, they're parallel. And then you tighten the screws really tight so that it remains parallel to the build plate or to the bottom of the vat there. But somehow it's worked out well. So I don't know if that first layer, there's just enough space naturally between the bottom of the build plates and the silicone coating on the bottom to just allow it to print, or some other mechanisms behind that, but I didn't have to do any kind of Z height calibration there. So I'd love to sit here and answer tons of questions, but I don't want to take up too much time. So I'll have all of the pieces in the back after all of the presentations. You can come back, ask me questions, talk about it. I'd love to talk your ear off because I think this is really freaking cool. My last plug is I have a YouTube channel, Hoffman Engineering, if you don't follow me already. I have all of my cool personal projects. That's actually where I kind of document all of my stuff. So if you're interested, I'll have videos up showcasing kind of my projects on this. And if you want to make anything cool, contact me. Send me models. Get with me. I want to make awesome stuff. So let's print your things. So, thank you guys.